Welcome to this EDUcast, Voice Quality Management Beyond the Network, sponsored by Versailles and Telecom Reseller. This is Gary Auden, and with me today is Ross Williams, Chief Operations Officer at Versailles. And as we always do, we're going to talk about what we're going to talk about. We're going to talk about something called the ITIL and why it's important. It's a library or function or a way of looking at managing resources. Versailles has also come up with some statistics about measuring voice quality and how it relates to mean opinion score, and we'll discuss those. Notice that the next four titles each have the word management after it, but the reason why we have four different titles is these are four different types of management. Let's start off with this first slide. And would you tell me about ITIL, because not everyone in the audience knows what it is.
Okay, so ITIL or ITIL, it's a service management framework that actually originated in Europe, and it's had a great level of uptake around the world, and it's become very popular for managing IT operations. One of the reasons that it applies really well to the world of unified comms and contact center is that it puts the user in control, so that the ultimate judge of the quality of services that IT provide becomes the end user or the business. The other thing that's really useful and really applicable in the UC world is that all of the processes interwork, and we'll see through the presentation how that comes together. These environments are pretty complex, and they need management at a lot of different sort of levels, and ITIL brings all that together and makes it pretty cohesive, particularly how it pertains to voice quality.
Now on the next screen, there's a statement here which lots of people think about, but could you articulate that a little bit more for us, because I think it's a good statement.
Well, yeah, that's an old management adage. You know, you can't manage what you can't measure. We've added on to that you can't measure what you don't know exists. And that's because these environments, these unified comms and contact center environments, are complex environments. And they're far from static. They're also always on the move. You know, there's a lot of touch points in getting a call, incoming call through to an agent or through to an IVR, then onto an agent. And there's a lot of touch points that a lot of people don't necessarily know exist.
Well, I would think that presents an awful lot of challenges here, and I see four of them on the screen.
Yeah, well, this is the typical challenge that a lot of people face on their day-to-day roles. I like to call this the circle of death. I think a lot of listeners will be able to relate to this. Their users complain that there's poor quality calls. The voice team get involved in this, and they do their troubleshooting, and they say this must be a network issue. They hand the issue over to the network team take a look at their side. They say that there's nothing wrong with what they're doing. They're not seeing any issues on their side, and they try and hand it back to the voice guys, and we're at an impasse. You know, the circle's just continuing. The result is for the end user, they're still suffering poor quality from time to time.
Would you say that some of these challenges are that the voice quality problem is transient, and once you get there, it's not a problem anymore?
Oh, absolutely. Absolutely. You've absolutely got to have historic data to go back and look at what was going on when the problem occurred. If you look at what's going on now and try and recreate the issue, most of the time you're not going to encounter the same circumstances.
Now, ITIL actually is a hierarchy here. Can you explain this to us?
Yeah, well, what we've put together here is showing all the moving parts, I guess, that go together to produce a good quality voice call. There's a sort of a perception out there amongst a lot of people that RTCP is where it's at, and the way we've drawn that up there is that's the tip of the iceberg. So RTCP is related to the performance of the network, I guess. What we're saying that underneath the tip of the iceberg, there's a whole lot of stuff that has to be right first before we start looking at the network. And this hierarchy brings it together, and from its level of importance, down the bottom there, DSP version, that's fundamental, and that's covered under release management, and we move into configuration management, capacity management, before finally looking at availability, the network side. So this is a good depiction of ITIL in action as it applies to voice quality.
Your company, Versailles, has analyzed a lot of phone calls. The numbers here, I think, are almost staggering how many you've analyzed. What have you learned from that?
We ran this exercise just recently, actually, and it was quite enlightening for us. We looked back over the last 30 days of calls made by our customers. The last 30 days, 257 million calls. So we had a very good sample. The reason we're able to do this is that VoIP Service Management is a cloud-based application. So all of our users are effectively using the same platform hosted in Microsoft Azure. So there's an enormous number of transactions that we're able to capture and process, and of course we're looking at these on a anonymous basis. But what it says to us, 99% of our users are enjoying very good voice quality. So that's a mean opinion score of 4.0 or above. A much lesser number, only about 2.1 million calls were satisfactory in the 3.6 to 3.9 range. Not quite business quality voice, but still, quite usable. And only 400,000, in fact, 0.2% of our entire base were getting a MOS score of less than 3.5, which is pretty scratchy, and the users definitely won't be happy at that level.
Would you say mean opinion score is a metric everyone in the industry should work with?
It's kind of the default, the accepted standard mean opinion score. So this came about back in the TDM days, and it's a way of assessing the call quality. So the perfect call, if you like, which is not really achievable in the real world, but the perfect call has a MOS of 5. Anything 4.0 and above is considered business quality. And as you go down the scale, it gets worse and worse. So you really don't want to be having any calls that are below 3.5 if you can avoid it.
Now, this set of interesting statistics is really based on a lot of work you've done. And can you relate it back to that pyramid, the hierarchy we saw earlier?
Right, yeah. It's a good example here. We've taken all of those bad calls and taken a look, put them under the microscope. And again, using big data analytics, we're taking all of the feeds we're getting from our customers and taking a look at them on that under that microscope, under the ITIL hierarchy. So pretty fundamental down the bottom there, DSP version. We can't necessarily relate this directly to voice quality, but what we are able to ascertain is that 1/3 of our base are actually running on out-of-date firmware. So the manufacturers recommended a later release, and only 2/3 of our base have done that. The remaining 1/3 are running behind. That's particularly when we zoom in and look at the stuff that's important to voice quality, like the DSP version.
Let's go and look at this in a little more detail. Why is release management important to us now?
Well, I guess people are starting to relate to release management more and more, and the importance of running the right release. And sometimes it can come down to the right release for your hardware. Most people can start to relate to this now if they just think of their smartphone. So if you've got a smartphone application, you're running an iPhone 6S like myself, and you've got a problem with one of the apps that you're running, perhaps your banking app isn't working properly, and you go to the store and you can see there's a later version of that app available. You're not going to bother trying to get hold of the bank or talking to anyone else until you go through and upgrade that to the latest version. I think everyone can understand there you're just wasting your time not running with what the manufacturer says you should be doing. So that's pretty fundamental that we do keep these environments up to date, particularly if there's a problem.
The next slide deals with configuration management of the endpoints. Which one of these do you think produce more problems than others?
Well, starting at the top there, this is something we can absolutely tie back in, looking back at that hierarchy, particularly if you have a speed or a duplex problem on your phone. So if your phone's running at 10 meg, or particularly if it's running at half duplex, you're trying to drive a car that's got 3 wheels. If that's the case, that is absolutely a problem, and that needs to be cleared up. As we move through that list, another common thing that we see is the VLAN. So the Avaya phones, when they boot up in the broadcast VLAN 0. That's how they work. and from there they look for DHCP and so forth and start picking up information related to their configuration. If they don't get themselves out of VLAN 0, so in other words the scope they pick up incorrect or something goes wrong and the phone stays in VLAN 0, it's never going to get good voice quality because that's the broadcast VLAN. So more or less QoS doesn't apply in the broadcast VLAN. So anything sitting in VLAN 0, if it's an IP hard phone on site, that's going to be a problem. And the last big one there is the DSCP audio priority. If that's incorrectly set or that doesn't align with your QoS model, that's going to be a major problem as well.
Now the next slide also says the words configuration management, but we're talking about a different area, the IP network region. Would you explain that to us?
Okay, so regardless of the manufacturer, the concept of network regions has to apply. And this is when you have particularly when you have a distributed network. So not many customers will run a company-wide LAN. They may do if they're relatively small or if they're on perhaps a campus where bandwidth isn't a problem. But any business that's distributed will have WAN connections. So what the concept of network regions does, it allows a picture of your network to be drawn inside the minds of your call servers. So in the case of Avaya, inside the mind of communication manager, inside the mind of session manager, there is a map of the network. And that map allows the applications to understand bottlenecks. So when the application is managing calls that are routing from A to B and perhaps going across a WAN link, those applications understand where that WAN link fits into the call segment. And that's really important because WAN links are narrow, so you don't have the full amount of bandwidth available to you. And incidentally, moving forward, Avaya are moving that whole concept of IP network regions, they're moving that to a single piece of configuration. So session manager and communication manager are going to combine from that point of view. So there'll only be one pace to do that configuration.
Let's talk about capacity. And one of the things I'm interested in looking at this particular display is how peaky the traffic is. Is that normal?
Yeah, well, it comes down to the nature of the business, I guess. Some customers are quite consistent in their bandwidth usage, but call peaks can be quite brief. And so what we're doing here is we're picking up the bandwidth that's used on these network region connections. And the main reason we do this is because that most engineers, most administrators, they don't know how big the real-time queue should be. So what we're doing here is we're actually measuring what the application is using. So this is real information, so it's not speculation. It's real information based on even right down to the codec set. So some codecs will use a different amount of bandwidth than others. So we combine all of the different codecs, all the different calls that are going over the different network regions at any one time, and then we can produce exactly what bandwidth is being used. So in the case of talking to the data network guys, it may be a case that that connection there shouldn't be 512K, it should be something much greater. In this case here with this customer, we're looking at about 3.9 meg. So it's important that those, just as the other QoS settings are aligned with the data network guys and what they've done, it's just as important that the size of the real-time queue is also in alignment.
Let's continue with capacity management, but this is interesting. Media resources. Would you help us understand this?
Okay, media resources are an important part of the architecture. You've essentially got to have enough media resources at per location basis. So they are physically tied to a physical location. A bit like trunk groups. If you've got a trunk group coming into a site, you've got to make sure that trunk group is big enough to carry all the traffic that's being presented to that site or calls that are being made out of that site. By the same token, DSPs, media resources, they're in exactly the same boat. You've got to have enough of them at the various sites to cater for the loading. Now, interestingly enough, trunk group information is very easy to get. It's something that people measure all the time. They make sure they've got enough trunks, got enough headroom to cater for all of their traffic. But when it comes to DSPs, which are equally or arguably more important, the measurements are very difficult to get hold of. So what we've done through VSM is we run the continuous measurement of these resources, and we can tell you exactly on a per site basis, like we're showing on this graph here, exactly how many you're using, expressed on a percentage basis. So that's the other thing. The media resources come in different size packages, if you like. So the best way to look at them is on a percentage consumed basis, and that's what we're presenting there.
Next screen covers the word availability and then says DS1 Sync. Can you explain that to us?
Yeah, DS1s, I mean, this is going back in time a little. DS1s are circuit packs that support things like ISDN trunk groups. So they're a TDM type resource. When Avaya made the transition away from being a hardware vendor and really took on an architecture that supported distributed IP networks, the wheels fell off a little bit from a synchronization point of view. So DS1s sit inside media gateways, they sit inside port networks, and it's really important that they are synchronized because there's no longer a TDM bus that's connecting those media gateways and port networks like there used to be in the old days. So they need their own independent sync source. Now, this is a part of the configuration that's often overlooked. So if DS1s aren't set to sync, it does cause an audible problem, and it also makes your trunk groups less reliable. The best analogy that I use for synchronization for DS1s is you've got two trains traveling down a track, parallel tracks. If the two trains are going at the same speed, you can pass packages across out the window to passengers in the other train, and that's an easy thing to do. That's what happens when DS1s are synced. If they're not synced, you've got one train that's going slightly faster than the other. And passing those packages across that happen to be voice packets, passing those packages across becomes a lot harder. And every now and then, one train will completely be out of alignment with the other train, in which case you've got no packets going. And that's when you get an audible click. And a lot of people will think that's packet loss, and they start hunting down audio problems on the IP network, when in fact it's a plain old TDM issue. And it's very easily resolved.
Now, the next screen shows me something from one of your reports. How does this screen help me understand what you just said?
Again, this is looking back inside a real customer inside the communication manager. Very simple command that anyone can run. That's an administrator there. So you can see at the top there, they can run status synchronization. Now, what you're looking for, if the synchronization is working properly, the synchronization source will be a DS1 board. And you can see there, looking at that left-hand column, port networks 1, 2, 3, 4, they're synced up nicely. They're using a DS1 board as a sync source. So those trains are traveling down the track at the same speed. And then from port network 5, and particularly into the media gateways, you can see there the sync source is not a DS1 board, it's a tone clock or a local clock on the media gateways. So all of those media gateways there, the trunks on them will be producing an audible click from time to time. And it was also that there's a reduced reliability on them because of the sync. The lack of sync gets bad enough, the trunk group can restart and drop all of the calls. This is as I say, is a very, very simple thing to sort out. Just a few quick commands there, and you sort that out and make that problem go away.
Let's continue availability management. Now we're up to the top of your hierarchy, RTCP, which is reporting statistics from the phones about the quality of the call.
Yeah, so in Availability Manager, and I'd like to emphasize that we shouldn't be in here unless we get all the underlying parts of the configuration correct. But once we're in here, we start looking at the real-time control protocol. So voice travels across the network as RTP, as a real-time protocol. There's a control element to that that Avaya and other manufacturers have quite cleverly used for to help troubleshoot voice quality issues. So what RTCP gives you, it gives you a lot of information, but the key ones are, it tells you the codec that's in use in the RTCP, and also tells you network statistics around jitter, latency and packet loss. So those are the big ones. We take those figures and we use a published open standard to make a calculation and come up with a MOS score. So what that's saying is, provided the latency, the jitter, the packet loss are within certain bounds on a per codec basis, we're going to get good quality voice. It also helps us in troubleshooting. So if the jitter, the packet loss latency, is not within the recommended standards, we can see that on the call. So we can see that historically. And really importantly, down at the bottom of the slide there, where we've got a red box around a piece of information there. Really importantly, in RTCP from a VIA, we get a trace route. So that shows us every layer 3 device that the call touches on its way across the network. So that effectively gives us network path. And when we look at that trace route, what we're looking for there is delay. And you can see that that one's got a red box around it. The delay there on that first hop is 576 milliseconds. So that's a problem. That's, if that was a problem call, and it would be a problem call, that's the router to take a look at. So that very first hop, that latency is just well outside of the bounds of what should be considered normal for a good quality call.
Now, Versailles been in this business for a while, but what is it you're bringing to the industry here? What technology leadership are you bringing to this problem?
Well, we're very pleased with the decision we made when we first went into business to make this a cloud-based application. We were one of the first into the cloud. We're a big chunky customer for Microsoft and their Azure environment. So we're using data centers that are all over the world. We had to create our own technology so that those data centers and the servers within the data centers could be used on a shared basis. But what the result is a true cloud application. So we're not talking here about an enterprise application that's merely hosted somewhere. This is a true cloud application, which means there's one application for us to maintain and support for the entire world. So we now have millions of endpoints under management via that application. And the speed to market that we get is quite tremendous. So we run a continuous development process and behind the scenes, and we run out new software every Tuesday, every Thursday. So this is very, very different from an enterprise application that remains relatively static. This continually moves ahead, is continually upgraded, and our end users don't have to do anything to enjoy the new features, new functionality, and the bug fixes that come with that. It also allows us to get hold of those big data analytics. So we, in our databases, we have every single call that's made by every single one of our customers from a voice quality perspective, like we looked at earlier. But in fact, there's a whole lot of other metrics we pick up as well. And our average customer globally, we run about 285,000 commands per day. So it's a completely different picture to enterprise-based applications. We look at across that entire base, and we look at precursors. When there's a particular outage, we can look at precursors, and we look at the common factors that we see prior to an outage, looking for those precursors. And again, across that entire base gives us a huge amount of information to go by, and we can start building predictive algorithms. So in a lot of cases, we can predict an outage before it happens, and we can open a ticket via an API or send off an email or however we're integrated. But we can predict an outage, and we can even give a predicted severity code for that outage. So we're starting to get on the front foot. This is really important for the business. It's far better to stop a problem from happening in the first place, stop that business disruption, than being really quick to fix it afterwards. It's better that it never happened in the first place. So we've got a growing capability around predictive algorithms too, just using that big shared data that we're getting from all our customers. And the more customers we add, the better that predictive nature becomes. One last important part there is the workflow engine. So we understand that these environments, it's not a one-size-fits-all. So we have created our own workflow capability. Again, that's Versailles technology that allows the automated response to any sort of incident. In fact, any piece of information in our database can kick off a workflow that can cause an automated process to run. So for example, if we have a router that we know has got a known problem, and that's causing an issue that will cause an alarm or some sort of event to happen, when we see that event, for example, we can script up to log into that router, take the same sort of actions that an engineer would to make that problem go away. It might be just a reset of a port or something and then log off. So that becomes automated. So through that workflow engine, we're massively increasing availability. We're just taking what engineers would do, automating that process, and making that happen 24 hours a day, 7 days a week.
I'd like to point out for those who are viewing that Versailles has a lot of resources available, blogs, white papers, videos, and brochures. Just go to their website and you can look those up. This is contact information for Versailles, contact information for the company itself, and you can connect to Ross at the bottom there, which is not always the case with some of our EDUcasts. So you can actually talk to the man who's been on this EDUcast today. Thank you very much, Ross. I really appreciate the time and the insights you've given us.
Oh, it's been a pleasure, Gary. Thank you.